Okay, last class we have seen hardwired method of designing a control unit followed by instruction cycle, how the instructions are executed, and if any interrupt is generated, how the CPU take care of that interrupt by using interrupt cycle and mixing both the two cycles. Total program cycle we have seen last class by using the flowchart, right? Now today we will see microprogrammed control organization. Problem with the internet, sorry. Is it visible screen?
Yes, ma'am.
Okay. Right. Today's topic is microprogrammed control organization. So we have seen already how a control unit is designed in a digital computer with one way, that is what a hardwired method. Okay. So whatever is the control unit available in the CPU, it is responsible for generating the control signals. What are the control signals means? Which will select the one of the register in a common bus system. We have seen there is a mux that will select one of the register which will places the data onto the common bus and activate the either load control or increment control or clear control. Okay. And other controls like that will select one of the ALU operation. Okay, so these are all different control signals needed at a particular time instant so that your complete instruction execution procedure will be fulfilled. Start from the fetch, reading code from memory, after that decoding, and finally reading data item from again from the memory, and then followed by execution of any of the arithmetic or logical operation. Okay, these sequence of operations have to be fulfilled or need to be complete so that one particular instruction can be executed. Okay, at every stage you need to generate the required control signals that we have generated by using hardwired method, where we are implementing some certain we are implementing that control unit by using certain conventional logic gates or decoder units by using them. Okay, so simple logic gates are used for generating the control signal. So hardware we are using, hence we call it as hardwired method of implementing control unit. Okay, the second alternative method is microprogramming uh, uh, control organization, right? So here, let us see the principle involved here. So in microprogramming control organization, here the basic control function, whatever we want to implement, that particular, it specifies a micro operation in the form of a binary variable. If that particular binary variable is set, then it will perform one particular micro operation. Otherwise, the corresponding other micro operation will be executed. Okay. So this basically this control variable, if it is in one state, it will execute the corresponding micro operation. If it is in another state, opposite binary state, it may not change the state of the registers, or it may lead to some other micro operation. Okay, right? So mainly your control unit here in microprogrammed organization, it will initiate a series of sequential steps that involves certain micro operations. Okay, during a particular given time, all these micro operations have to be initiated and they have to be executed. Okay. Here, all the micro operations are initiated and the remaining will be in ideal. One micro operation is nothing but one particular binary variable. Okay, if it is set, then one particular micro operation is initiated. Otherwise, the remaining will be in idle state. Okay, so basically, microprogrammed control unit is it's a bridge between hardware and the software. See one example I will say. For example, if you want to perform addition of 2 bits, right? Addition of 2 bits, how can you do? By implementing certain maybe half adder. What it contains half adder? Half adder will be having gates. Okay, maybe one XOR gate and an odd OR gate that produce you, and gate that produce you sum and carry. Okay, so I will implement. I can implement the function of my addition operation by using the logic gates. Okay, sometimes I wanted to implement another function where I won't write, I won't use a hardware. For example, a multiplication if you want to implement. Okay. For multiplication, you can use any hardware which is able to perform the multiplication, which will take the inputs, and the multiplier circuit itself can be implemented in hardware, maybe by using certain available multiplier hardware circuits, maybe booth multiplier, or else there are several multipliers are available. Okay. Hardware unit values at different multiplier hardware units are available, by which you can even perform the multiplication. Or else there is another way where with the available hardware like addition and shift circuitry, by using them I can even perform the same multiplication operation. But how I will implement that means I won't write I won't use logic gates. I will write a program to perform that multiplication operation. Okay, that is one way of microprogrammed control organization. It's a simple example. If you want to implement any complex operation by using the available hardware, I can do by writing a sequence of steps that will do shift and add operations, which I can implement now the multiplication instruction rather than writing a program. Okay, if I write it in the form of a control set of micro operations, which will be stored in a particular memory, we call it as a control memory. Okay, so that will whenever a multiplication instruction is called, that particular program will be executed. Okay, so that function is defined by the a designer, not by the application user. Okay, this is the best example for micro programmed control unit. Okay, is that clear?
Yes, ma'am.
In hardware, we will use exact hardware for implementing any functions, but in microprogrammed control unit, we won't directly go by hardware. We will use a certain set of instructions with the available hardware. I could able to implement the next subsequent any higher level instructions or so. Okay, so it is like a bridge between hardware and true software. Okay, in deep sense, if you see in a basic level, okay, if you see in a basic level, there will be certain control variables involved. Okay, at any given time, these control variable are set or reset that will initiate several set of micro operations. Okay, okay, so all these control variables, whatever are available, those having set a string of ones and zeros, we will make every operation, every micro operation, we call that as a control word. Your a set of control words are now called as a micro program. Okay, so micro program, and it will be stored in a memory, which we call that as a control memory, not a simple or as if like a main memory. Okay, so basically whenever a micro programmed control unit is organized, right, we will be having two types of memories. One is main memory, another is control memory. Control memory will hold all the set of microcodes. We call that as a microprogram, right? Usually it should be of a memory which should not altered by the user, only by the particular designer. Okay, so it should be in read-only memory, which should not be updated every time. So these contents of words will be there in ROM. Those are fixed and cannot be altered by simple programming, right? And ROM words made permanent during hardware function of the unit, right? So a computer that employs microprogrammed control unit will have two separate memories. One is main memory, another is control memory. Main memory usually available for the user for storing their programs and their data. Control memory holds a fixed microprogram which can be altered by the designer actually, okay? And microprogram consists of micro instructions that specify various internal control signals for execution of register micro operations. Register level micro operations like, see, for fetch operation, you have to transfer contents of PC to address register. After that, read the 16-bit instruction code from memory. So these are all certain register level micro operations. To initiate them, these things, it requires a certain control signals. Okay, those control signals are now activated by using certain control variables. Okay, the control variables, the setting or resetting is done by your micro instruction. Okay, so micro instruction is just nothing but a set of ones and zeros, which we call it as a control word. Okay. So each micro instruction generate micro operations to fetch the instruction and to calculate the effective address and to execute your instructions, and a return control to fetch the next subsequent micro code. Okay, so it has to generate for the next address. Okay, it need to generate the next address to do to generate the next subsequent operations. Okay, the next instruction address may be it in a sequential or it may be somewhere in the other portion of the control memory. Okay, right? It is also as if like a program has to be executed, right? So every time whenever a program comes, the next instruction address need to be calculated, right? So the microprogrammed organization, if you observe, it is also having a cycle of operations. We'll be having one register which is called next address generator. It is also called a sequencer, sequence of micro instructions. Okay, addresses of all these micro instructions one by one. That address will be generated in this block, next address generator block, right? It will generate, it will gives you the address of the micro instruction available in the control memory. Okay, that address will be held by your control address register, and this will map to your memory, control memory, which produce you the control word. Okay, that will be copied on the control data register, and this control word is now gives it gives to activate different variables, which generates finally the control signals. Okay, from this control data register, certain inputs are taken for generating the next address of the micro instruction in your control memory. Okay, so what is the next address? To calculate the next address, the control in the control word itself, a few of the bits are used for generating the next micro instruction address. Okay, so from those control input, we will be having few inputs which are helped by which are used by your next address generator for generating the address of the next micro instruction in the control memory. Because the next micro instruction may be in a sequential, or it may be somewhere in the other portion of your control memory. Okay. Here we will be having certain words, important words like control word. So what is a control word?
It's a string of ones and zeros that specify a control function.
Control it. These are a set sequence of or strings of ones and zeros. We call it as a control word. Basically, the control variables at any given time, they represent series of ones or zeros, that we call it as a control word. Okay, your control unit, which is having your all these control variables, which are binary in nature, it can be set or reset. They are stored in your memory, which we call it as a control memory. Okay, right? And that is said to be the microprogrammed control unit. It is having series of micro instructions. The address of the micro instruction will be generated by next address generator. We call that as a sequencer. Okay. So this sequencer provides you the control address information, which is stored in your control address register, by which from the control memory, it extract the control word. Okay. So control word will be available in a control data register. These are the two registers. One is address register, another is data register. As if like your a PC and data register. Okay. So which holds the address of an instruction. When we talk about main memory helped by users, main memory mainly used for storing your program and data, right? Since here it is the control memory which stores control information, so we call the address registers as control address register. Similarly, it holds it holds a micro instructions which belonging to a control board. So hence we call it as a control data register. Okay. So your control board has the required information to activate the control signals, as well as a few more information which involves for generating the next address of your control micro instruction, by which the next address generator or the sequencer will generate the address of the next micro instruction. So this is what the simple microprogrammed control organization. The same thing is explained here. So location of the next micro instruction may be the one next in the sequence, or it may be located somewhere in the control memory. So for this reason, some of the bits present in micro instruction to control the generation of the address of the next micro instruction. Okay, so next address generator will uses this information to do so. The computed next address generation circuit, and then it is transferred to the control address register to read the next micro instruction. Thus, the micro instruction contains bits initiating the micro operation that determines the address sequence for the control memory. Okay. What about the sequencer? Sequencer or the next address generator. This is also called as a sequencer. Address of the next micro instruction can be specified in several ways depending on the sequencer inputs. Typical functions of the microprogram sequencer are usually, if it is the next instruction, then just it increments the control address register by one. Or sometimes it will load the control register from an address from the control memory. Transferring external address or loading initial address to start the control operations. Okay. See, your control address register should hold address of the micro instruction available in the control memory. So initially, first micro instruction address will be loaded as an initial address to start the control operation. Okay, from an external address. That is the first operation. Once it is loaded, the next micro instruction address is just by incrementing if it is the next sequence. Sometimes it is not incrementing. Sometimes it may be in some other location of the same control memory. Then you have to get that address from the same control board, which is available in your micro instruction. Okay. So the control address register has to load with another address from the control level. Okay, so this another address is available in the micro instruction itself. So hence we are taking some portion of your control word as input for your next address generator. Okay, it is as if like you are programming simple program. If you have branch instructions, right, the address PC will be updated with the address available in the instruction itself, as if like this. Okay. Next, address sequencing. This we will see in next class actually. So that's all for today. Actually, I too wanted to postpone the class, but I have some other work. Okay, so today this is sufficient, ma. We'll discuss address sequencing and later remaining topics in the next class. Okay, and just take the attendance and I will leave. Okay. Okay, ma. Thank you. I have collected the attendance. Okay. So just you can leave the class. We'll discuss.